All right, trig 8. We're going to talk about different angles, being able to draw them, but more importantly, being able to find what's going to be called a reference angle. So first of all, a standard angle is we draw an angle using a directional arrow, terminal side, and a label on the x, y, and axis. Our standard angle is something that we did back at the beginning. We were making angles off the x-axis as our beginning point, and then we direct if we're going upwards positively or downwards negatively to a certain degree measurement. The principal angle we're going to call theta. The principal angle is the angle you get that's between 0 and 360. It is the general start of where we begin, where we end. But what we're going to be using quite often and much more useful to us is going to be what's called the reference angle. The reference angle, and we're going to use alpha, which is this kind of fish-looking Greek symbol. The reference angle will be an acute angle. It is the acute angle that makes the 90-degree triangle in our other quadrants. It's always created with the terminal side, also called the hypotenuse, and the x-axis. The reference angle will always be between the x-axis and the hypotenuse. This little star thing, you want to highlight it, mark it, double check it, write it in bold, capital letters, because that creates our reference angle where we do almost all of our work at. All right, so we're going to look at some different measurements here. Here I have some examples of 120 degrees, 211, negative 293, and 660 degrees. Now keep in mind, I can call this 120 degrees, or I could call it 2 pi over 3. I could put it in degrees or I could put it in radians. It really makes no difference whatsoever. You know how to switch from one form to the other. However, whatever measurement form your question is in, degrees or radians, that's how your answer needs to be. So if it starts in degrees, you end in degrees. If your problem starts in radians, you need to answer in radians. Even if in the middle you changed it to degrees, that's fine. Just make sure your answer always reflects the form it started in. So if I'm going to draw 120 degrees, I start with my x-axis. It has labels, and I'm going to start on the x-axis. That is my beginning point. I'm going to 120, so 120 is about there, or the 2 pi over 3. I put arrows, and I put my directional arrow. So I went upwards from 0 to 120, and I label it. I label it in the form I'm given. So if the problem's written in degrees, I write 120. If the problem was written in 2 pi over 3, I'd write 2 pi over 3. All right. What we're going to do is, once we create this angle of our given, we're going to look at this reference angle. And the reference angle is always between the hypotenuse, which is the terminal side, and the x-axis. Now the nearest x-axis happens to be 180. So if I know this angle went 120, then alpha must be the remaining distance. So in your assignment tonight, what you're going to do is you're going to say the principal angle, in this case, was 120 degrees because that's what was given. It's between 0 and 360. And alpha, the reference angle, is the angle between the terminal side and the nearest x-axis, which in this case is 60 degrees. Now, if this would have been a problem written in radians, I would have said 2 pi over 3, and then 60 degrees is pi over 3. I would have answered it in radians. All right, if my angle's 211 degrees, so I make my axes. 211 is going to be, I don't need a protractor, but I know it's going to be somewhere about there. So I start at 0, and I'm going to go past 180 and a little bit more. So there's my directional arrow, and there's my label. So my theta is 211 degrees. Now my alpha, my reference angle, is always the terminal side and the nearest x-axis. So it's from this 180 to 211, and we get 31 degrees. Because I went past 180 to 211, so I would subtract the 211 and 180 and get the 31 degrees. All right, negative 293. Negative means I'm going downwards. I'm going to go to 180. There's negative 90. There's negative 180. There's negative 270. So I'm going to be going past here to maybe about there. So that's negative 293 degrees. I make my graph, I label it. I now am going to put my my principal angle, or my major angle here, but the principal angle, remember if we go back to our definition, the principal angle is between 0 and 360, not negative 360 and positive 360, but only the positive angles. So when I'm looking here, I'm only looking at the positive measurement of my initial side to terminal side. So in this case, if this is negative 293, then if I were to finish this out, it would be up to 360, so 67 degrees. So my reference and my principal happen to be the same thing, because the principal is the positive measurement of my final angle. This is my final angle. Even though the original was obtuse, or much more than obtuse, and it was negative, I can only have a principal between 0 and 360 positive, and the reference is always between the nearest x-axis and the terminal side. So if I'm in quadrant 1, the principal and the reference have the same value. All right, 660. 660 is going to be going around. There's 360. So I've already gone 360 of it. I need to go 300 more, which would put me about there. So there's my beginning, there's my end, there's my label. Now when I'm looking at my principal angle, the principal angle is only between 0 and 360 from beginning to end. So I can only go positively from beginning to end. This is going to be another 300, so that makes that 300 degrees. Alpha, on the other hand, is from the terminal to the x. So it's the smaller piece here, which is 60 degrees. Now in your assignment today, you're going to be making these angles. You're going to be telling me the principal angle, and you're going to be telling me the alpha, or the reference angle, and they have to be within those guidelines, 0 to 360, 0 to 90. All right, a couple things I want to talk about is, why does the sine of 50 degrees equal the sine of 130 degrees, which equals the sine of negative 310 degrees, which is equal to the sine of 770, which is equal to the sine of negative 950 degrees. Why is that true? I mean, sure, I can put it in the calculator. I can go, okay, sine of 50, sine of negative 310, sine of 770, sine of negative, where are we at there? Sine of 130. I think I wrote that number wrong. But what happens with all of those is that they all come out to be the exact same value. We're going to cross this last one off just because I don't know what happened with that, and don't really have time to go through and fix it. So why are all of these the exact same value? Well, we can plug in the calculator. That's true. But what happens if here is the sine of 50, here's 50 degrees, I have a y value, I have an x value. Great. It's in the first quadrant. Okay? Well, sine of 130 is in the second quadrant because here's 130 degrees, where this is 130, but the reference is 50. Well, if I'm in the second quadrant and I'm sine, I'm still the same y value as if I was in quadrant number 1. Negative 310, well, 310 is over in the first quadrant. 310 gives the reference of 50, so I'm the exact same triangle. Sine of 770, same thing. What we're getting to here is that these are the same triangle in quadrant 1 and quadrant 2. When I say these are the same triangle, they're the same triangle with the same y value. The y is positive in quadrant 1, the y is positive in quadrant 2. Now the same would not be said for cosine. Cosine 50, cosine 130. You're going to get one positive and one negative, and let's just kind of prove that quickly on the calculator. Cosine 50, cosine 130. Notice they're the same value, but one's positive and one's negative for this reason of quadrant 1 versus quadrant 2, and what SIGNs are positive negatives in what quadrants, and we learned that in the last section. So what's important to recognize is that when we have same triangles, we're going to get same values. All right, let's look at a true-false question. Cosine of 41 is the same as cosine 221, and tangent 34 is same as tangent of negative 146. I want you to answer that question and be able to give it to me in class tomorrow. And then, is cosine 212 degrees positive or negative? Granted, you could flip a coin here, but also I want you to tell me why. And I want you to be able to answer those two questions for class tomorrow.